I'm Vaughn Watson. Joining me today is Mike Frazee. Michael is a retrofit specialist on ammonia systems. Travels quite a bit to power plants and other facilities to assist them with their process systems needs. Mike, how you been?
Pretty good.
Yeah? Holidays treat you okay?
Yes, sir. Yep.
Happy New Year.
Thanks, you too.
Have you been a lot of places recently?
Not this year, obviously, but yeah, last year I think I visited over nearly 40 different facilities.
Yeah? What kind of places have you been?
Which I would guess is some kind of record for me, but everywhere from,
Yeah, where'd you go in December?
Well, I was going to start at the beginning of the year, was what I was thinking about in December. I don't know, I have a whole list of places. The last place I traveled to, where did I fly to last?
You were out with the folks in the Southeast, I believe.
Oh, I flew to Georgia last.
What'd you do in Georgia?
So we had a request for a quote from one of our reps in tech products, who we work with frequently, but they had there's a RFQ for a fuel gas separator. Yeah, this is just a power facility generating power.
Gas fired?
Yeah.
Okay.
Yeah.
Gas turbine?
Yes. And so they need this is something that we had quoted way in the past, but it's finally gaining traction, and it's going to go out for quote. There was, three of us. There was a required site walk.
We've been doing quite a bit on the fuel gas conditioning equipment. Not only through the API 560, which George is on the roundtable for, but more and more customers are having fouling issues, and it's become to where it's now a requirement, not a nice to have. So a lot of that fuel gas conditioning equipment falls now under safety, because if the burner or whatever the combustion source is gets fouled up, it can cause an explosion, right? You can have gas that's building up and poor ignition and so forth. The other thing is we're starting to see black powder becoming more and more prevalent. And black powder, not gunpowder, more like waxes and iron sulfate that forms in the gas. And so when that's burned, it leaves behind this thick black sediment that's not only corrosive, but also tends to foul things up and reduce efficiencies and cause other havoc. So yeah, black powder is one thing that we've been doing a number of fuel gas separators for, looking at a plant in Longview, Texas. That's probably my most recent site visit. Went out to Longview with Murad and taking a look at a separator design to take care of that. They're not only having to heat the gas to get it above the dew point, but they're also trying to remove as much of that black powder from the system as possible so it doesn't foul up their processes. I believe that facility in Longview, they're putting in a new boiler at the end of the year, and so they're trying to get the fuel gas equipment in place before the new Rentec boiler gets installed.
Nice.
Yeah.
Yeah, well, on that site visit that I was at, I just so happened to walk past or met with the maintenance manager. And of course, when I'm walking on the site, I'm talking to the guy who's walking us around, and I noticed the hot gas fans over on the SCR skid. I'm like, how are those hot gas fans treating you? And he's like, oh, they haven't been too bad lately, but they have the typical bearing failures and vibration and stuff. So I did find an opportunity to provide a quote for that as well, because we do
Upgrade the bearings and everything.
Well, upgrade the bearings. Yeah, they had pillow block bearings on that system. So of course, I mentioned the oil bath housing for an upgrade, longevity, and then of course isolator springs on the base, the fan base.
Yeah, dealing with vibrational issues.
Yeah, so both of those things, as we've had them out in the field for
15 years.
15 years,
Yeah.
really 15 years now. That worked really, really well. So.
I got a cool fan one that I saw here recently. Been talking to a customer out in the New England area, right outside of Boston, and it was a small system. It's a vector skid from way back when, but they have regenerative style blowers, and we were talking to them about a number of things, and they had gotten a sample tested of some debris on the catalyst, and it was tested and determined to be an organic, and we couldn't figure out where it was coming from. Well, upon them tearing apart the inlet to these little regenerative style blowers, the fan had actually sucked the muffler packing. You know, these fans, they have an inlet and an outlet, and they can be either fan or vacuum depending on how it's piped. But it had sucked the muffler insulation through the dilution air line and ended up plugging up a big wad in the AIG, and it had made it to the catalyst face. So
wow, that's crazy. How did it get through the AIG?
I'm assuming it just broke into particles as it got heated and, you know, doused with, you know, anhydrous ammonia.
Right.
But that ended up plugging up their AIG. They had major distribution issues. They had major, you know, fouling concerns. Obviously, the piping was all obstructed with that silicate or basalt type insulation fibers. And you know, they tested the catalyst, and it had it on there as well. So they've cleaned the catalyst. I believe they've gutted the mufflers on that thing for now to see how it runs. But that's a new one on me. I'm pretty familiar with the regenerative fan style systems. I know they get pretty hot when you talk about, you know, an ambient air fan heating up 100+ degrees over ambient. It's just a matter of time, I think, until that breaks down, that material breaks down and gets ingested by the fan. And, you know, I had told the customer, I'm like, wow, that's a new one for me. I've only seen damage to those fans on the other side, on the plastic impeller side, on the motor side of those fans. So that's a new one. I put that in the diary of site issues.
Field, yeah.
I know next week we're planning on going out to Alabama. We're going to be meeting with NTEC and UDC, and there's a few other folks that are going to be out there. But I'm getting the opportunity to present on distribution issues that systems have. Be real similar to what I presented back at Combined Cycle Users in Tucson, or Phoenix rather. But we're going out there, going to be meeting with, I guess, 30 or 40 plant end users on issues that they're having primarily with their HRSGs. And so, you know, it's good that we can get a congregation together, and I'm going to be jumping in to the middle of UDC's presentation on maintenance, HRSG maintenance and inspections, to talk about, you know, some of the woes that these plants face with their ammonia systems and with the SCR, primarily around fouling and distribution, AIG.
Maybe I can find it later, but I guess one of the ways that we could kind of discuss and talk about issues we're seeing in the field is to look at our quote log.
Yeah, I mean, I think, you know, we walked through the shop earlier. There was a number of projects that I think are pretty special in and of their own right. We've got the largest aqueous ammonia vaporizer that we've done that's being built right now. That's for a project in Oklahoma on a J-class turbine, real big, and it's sized for 18 to 2,000 pound an hour of aqueous ammonia. It's all stainless steel. That particular unit's got a startup heater, so it's a hybrid skid design. You know, hot gas fans, but also has the electric heater to boost the temperature during startup for vaporization. So that was a cool one to see out there. They're about 25-30% done with assembly. And then the fuel gas separator skid that's out there now, that's impressive. Those 3 big vessels on skid. Right now it's being assembled for test fit, and then we're going to have to pull it all apart. The vessels need to be painted, and then from there, because of the height of the vessels on that skid, we're going to have to ship the vessels separate from the skid base, and the platform's going to have to be removed and so forth.
Yeah, that's kind of crazy that we have to put it all the way together and then disassemble it before we ship it.
Yeah, I know we've got, you were talking about fans earlier, we've got probably, I don't know, 8 to 10, maybe a dozen fans in the shop right now, of various types. I was looking at some of those earlier, just comparing the differences.
So, talking about issues, I was just looking through the CRM to see something recent. Wow, but we've been following this one for what?
Oh,
6
decades.
years, 8 years, at least since we heard about them having some issues out there, and now we're finally doing a vaporizer retrofit.
Yeah.
So how
What
did
el-
that start? So now that you're saying we're making these retrofits, how did that conversation start with that customer?
That particular customer, there was a consultant that they had been working with. They had made some changes to their operating profile prior to that, so they had done a GE combustor upgrade. They were actually making less NOx, but requiring more ammonia. And that particular one, the 15-year-old vaporizer was kind of borderline size from the get-go from another supplier. And so we're putting in a larger heater and a larger vaporizer, stainless steel because it's right by the coast.
Are we doing a larger heater?
Yeah, it's going
And
from,
we're doing the heater power panel as well.
right, yeah, so it's going from like 90 kW full out to, I believe, 120 kilowatt heater. So that's gaining them, another 25% of operating capacity.
And so the ammonia usage is what prompted it?
Yeah, they're still using quite a bit of ammonia. Plus, they still had the age of the equipment, right? So the fouling and degradation of their existing heater and the existing vaporizer.
Heater issues, of course.
Yeah, so they
As
were
time
having
goes on, I mean,
they were having a number of concerns that I think this addresses. And this is kind of a means to the end, right? You can replace the skid in kind when it gets to the end of its useful life, when the components that need to be replaced and upgraded potentially start to outweigh the cost of replacing those components. You could look at doing an entire skid replacement and now having modern day instrumentation and valves and a number of other components brought up to modern day spec. In this case, they had a window for their outage that they were trying to hit, and they wanted to get a solution in place, but also maybe grow into a replacement skid. So not only are we building them a new vaporizer and a new heater and heater power panel, down the road, they may switch out, say, the ammonia train or the dilution air fans. That way they're kind of getting themselves a new skid piece by piece.
Yeah.
While they can continue operating and limit some of that capital cost.
Yeah.
But
Which is cool and all, but you have to consider the amount of time that it's taking to do each one of those individually, and a new skid is a lot faster.
from a field rework perspective, yeah, I mean, we can replace a skid provided it lands on the existing concrete in a few days.
Yeah.
And that's, pretty turnkey, start up and ready to go, as compared to, okay, now we're talking about doing a bunch of wiring in the field and maybe some structural modifications here or there. But no, I'm glad you brought that up because that area is seeing quite a bit of changes because of policy, administrative policy.
Yeah,
so Governor Newsom in California had imposed some regulations that is putting pressure on some of the bigger industrials in that area, folks that are refinery owners in that area. They've been grandfathered in for many years, and some of the existing original infrastructure out there. What they're realizing is, hey, it's going to cost me more to comply than what it's worth. I can close the operations here or parts of the operation here and relocate to, let's say, the Gulf Coast or somewhere like that and have some advantages. It'll be interesting to see, this is a new year. I believe the inauguration is, 13 days from now. So I expect to see energy policies becoming a big aspect to the new administration that we're going to see. And it should mean good business for us.
What do you think that's going to make them less stringent? Or
No, I don't
I don't think there's any stopping the the movement of.
Here's what I think. It's going to be more deregulation, right? So, and I've got an example of this, but like you've got, it's not that they're going to lower the air permits so that people can pollute more.
Right.
What's going to happen is it's going to be easier to apply for a permit to build a new plant or add a new unit, right? So the permitting red tape should decrease. The costs for permitting should decrease, which is going to incentivize people to build. You're talking about putting in more efficient equipment than what's out there now, and that's got a trickle down effect to where they're making less NOx from the get-go and
using less ammonia,
using less chemical, the whole 9 yards. I did see Mike, I believe it's Mike Moore, president of the API. If I got the name wrong, I'll apologize, but I saw on the news last night they were interviewing the president of the American Petroleum Institute because President Biden has called up a coastal waters law from the 50s, and so they're basically putting a stop to all permits offshore along the coast. So you're going to have drilling, exploration, or even power generation that's on a barge or a rig or anything like that, now going to be put a hold on it. And this is going to require congressional authority to reverse. It's not a executive order. So you're talking about policies with the outgoing administration that are now coming to play in the last 10, 15 days of the presidency that are going to affect future energy policies over the next few years. So I think that's one of those things that, we're in a changing landscape, both from energy is what we're trying to do and do so efficiently, but also we're trying to become independent on our own sources of energy. So I don't know, it's interesting to say the least. I think we're going to have a lot of opportunities to look at doing process systems for these types of projects, but the projects may individually have red tape that needs to be overcome, so that deregulation can't really come fast enough.
Yeah.
But by no means do I think suddenly places like California or Massachusetts are going to require
raise their NOx limits.
Yeah. The NOx limits I don't believe are going to change at all. I think it's mostly coming down to what the deregulation and permitting requirements are.
So, I mean, I'm all over the place, man. We got fiberglass kilns, we got replacement heaters, distillation columns, vaporizer AIG upgrades,
Looking at
scrubber vessel.
oh well, we're doing fuel oil, dual fuel skids in-house right now. So that's a plant that's adding a secondary fuel to have that redundancy, not be so reliant on a single fuel source to generate power.
SCR frame replacement. We have some older Vector Systems box heater style
Dilution.
to vaporize ammonia
Uh-huh.
that we no longer use. We're using immersion style now, so I guess some of the problems with those are once an element goes bad, it's very difficult to get into that box style arrangement and just remove the the coils, and then some of them are obsoleted as well. We can't even get those manufactured anymore.
Plus, we've been doing immersion heaters for a decade plus now. So I think the age of those units that are starting to see those failures, it's well overdue for a skid replacement or certainly a retrofit upgrade to their heat source.
And so that was kind of one of the things I do need to look into more of how many of our older customers have those still, because if they end up having a failure, they're not going to be able to get a replacement.
Right. And those plants, they may not realize that they've got a failed element until they go to vaporize a larger quantity of ammonia, and all of a sudden
They can't keep up.
they can't keep up, and it's tripping because of liquid carryover. it's quenching that thermocouple, closing the control valve, and they're like, well, it used to could be able to do that, but when it's operating on 3 out of its 4 circuits or what
Yeah.
have you, that becomes an issue.
Well, it's pretty cold outside. I guess some people will probably notice it pretty soon.
Yeah, they're calling for snowmageddon here in the McKinney area. I think Thursday we're going to get 5 inches of snow,
That's
is what they're
crazy.
saying.
And then it says that it's not even going to reach Houston. It's not going to reach my side.
Really?
It's going to be rain.
You know what's wild is like in 2021 we had that snowmageddon, and ERCOT had to get called up in front of Congress, and you know they wanted to know, you know, who's responsible for this. And I thought at that time there was going to be plants that were doing a number of things to augment or offer redundancy to their systems, right? Everything from, well, we want to be able to have X amount of quantity of chemical storage on site in case we can't get a delivery for 3-4 days. Or thinking back even further than that, I remember you and I in the Houston area working with plants right after Hurricane Maria hit, and you know they're like, hey, we need to do something to be able to operate in a condition that we're kind of in right now. And I'm surprised that more things haven't been done. There's been a few projects where, like, you know, you had equipment going to say Austin, and they lowered the design ambient temperature to like 0 or 8 degrees.
Because it does happen.
Because yeah, like you know, your 10-year, 30-year.
So
on record.
me and my wife were just talking about that the other day, and she was, because you know, she's worried that you know we may lose power. So I told you we got that generator hook thing in the back, straight to the breaker box.
Got the interlock.
Yeah, and well, yeah, it was during that freeze that what I had heard was that Entergy turned the units off, like they didn't even fail.
Well, I think a lot of that's
and then they couldn't start them back up.
Right. I think a lot of that's grid stability. Yeah, I remember looking at Xcel Energy's plant out in Minnesota, and they had, I think it was, it's Minnesota. They had to originally manually synchronize the grid, right? They had to like dial in the power as it was coming on, and nowadays it's all computerized synchronization. You know, gotta get the VARs just right to lock them in. But
why would it be that they shut down the units and couldn't start them? I don't understand why they shut them down in the first place, to be honest. I was pretty upset about that. I mean, if you have a catastrophic failure or failure for any reason and the units shut off when we lose power, fine, but why would you shut off my power in the middle of freezing temperatures? And then why couldn't they start back up? I guess I don't know the answers to these questions. But
it's like dominoes falling, okay? So like you have one plant that goes down, and now
someone else has to
pick up the load. Well, then you get this instability on both the demand but also the supply. And much like how I was referencing Xcel Energy having to manually synchronize all that, if you've got plants all over a region going down unexpectedly, it can collapse the whole. It's like a house of cards. It can collapse the whole thing. And now you've got forced shutdown scenario where you can't even bring it back up in time because of operational methods to get it back online. And you've got this instability in the power grid itself. So even if you did bring it online, you couldn't synchronize it because of how unstable the grid is. So it becomes this house of cards.
Are you talking about like frequencies and stuff to get?
Yeah, I believe the term is VARs. I'm by no means an electrical engineer. I'm a mechanical engineer. If you can't fix it with a hammer, it's an electrical problem.
Right.
But I think it becomes a house of cards where you get this instability between the plants producing power and high demand of everyone trying to stay warm. And if plants start going down unexpectedly and other plants have to pick up that load, that may be enough to disrupt operations, is them having to suddenly pick up that load.
Yeah.
That's the one thing that we don't have as a technology right now is storage of any of the energy that we're making. You know, you got to think a large plant isn't storing a single volt or amp of that energy. It's all going to a grid where it's all being distributed and used. And they follow load to match peak demand, but we don't have giant batteries.
They do in California.
Giant batteries?
They had a whole battery farm, dude. Where was that place I was at? It was one of the
Out by San Diego?
Yeah, but I went to we were just talking about this the other day. Right on the water. What is it? It's in near the pier, the famous Huntington Beach.
Oh, Huntington Beach. Yeah.
What was that? AES?
AES has a plant there, Huntington, and then
So they had two that I went to.
you got
while I
El
was there.
Segundo right there. Chevron El Segundo's right there.
And I don't want to misspeak, but there was an AES plant there that I went to after I went to Huntington Beach, and it wasn't too far away, maybe 30 minutes. But it was further inland. No, not Scattergood. It was further inland, just a little bit. But they when you drove on site, they had all those backup, whole farm of batteries. Yeah.
But we don't have the capability
I don't know how much it
to long-term storage power. You know what I mean? It's not like water, right, where we collect it in reservoirs and then filter it and use it and redirect it. The power that's produced
is
being used, and when we have an excess, it's a problem, and when we have a shortage, it's a bigger problem. And that's why you have a lot of these plants, you know, talking about emissions, a lot of these plants having to do load following, where you're now maybe have an HRSG that's capable of generating 250 megawatts, and now it's reduced to 40% of its capacity. Well, you can turn the engine down that far, but the characteristics of the emission control now needs to be able to meet compliance at that load. So while you're probably making a little less NOx, you don't have the temperature there to keep the catalyst on its efficiency curve. And then the CO catalyst particularly, a lot of plants have a hard time, less than 50% load, meeting their CO permit obligations. So those are some things where you need adequate turn down, but also a way to manage that load following and be able to control NOx and, well, just emissions in general across all operating scenarios.
Yeah.
I've seen a lot of plants, you know, having to do upgrades in order to either have a catalyst that's sized for that temperature window to include that, or, you know, we're talking about changing out the CO catalyst because now it's having to operate where it normally wouldn't. You know, maybe, let's say it's 30% load, and the CO generated at that part load condition is much higher. And so at full load, it's 50 ppm down to 5, no problem. At part load, you may be 150 parts per million, still trying to hold 5.